Greetings everyone, and welcome to another ID 110 instruction video. In this video, we will be focusing our attention on interior elevation drawings. And as before, it's probably good to pull up some information that will be helpful during the assignment. So I suggest that you print out or at least have available the assignment so you can refer to it in case you need some additional information. You'll want to get a copy or have available the drawing format drawing or information so that you'll know where we're going with the finished project. And then some additional information in terms of example elevations that we're going to be able to compare to this information as we progress with our own drawings. So having that available is a good starting point. Additionally, it's probably appropriate to stop at this point and think about these drawings as being just a continuation of those orthographic drawings that we've been working on for quite a while now. These are, as I've referenced in the lecture, multi-view drawings. And in so doing, that description tells us that these multi-view drawings require multiple different illustrations to show one object. And these interior elevations are just part of that group of drawings. By the way, these are very important to interior design. These are some of the most prominent drawings that interior designers use in establishing the design as well as documenting the design requirements. So it's probably appropriate at this stage to take a look at some information that we looked at in the lecture, maybe in a little bit more detail. That detail has to do with the orientation of the interior elevation. And in so doing, we have a symbol that is used to represent the interior elevations that need to be represented. So as a result, we have a symbol. It's basically a square turned on 45 degrees with a circle in the center. And this is an enlarged view of the symbol. The symbol is typically much smaller and is represented down here. But in that symbol, we have a standardization of how to look at placing and orienting ourselves with regards to these interior elevation drawings. It is important, as was mentioned in the exterior elevation lecture last week, that elevations need to have some sort of order. They need to have some sort of way of relating to each other in such a way that others can look at that information and interpret it correctly. So this symbol, as I mentioned, represents a square with alphabetic representations at all four corners. These are almost always represented as A at the top, B at like 3 o'clock in terms of its placement, C at 6 o'clock, and D at 9 o'clock. So as a result, we end up with A, B, C, D elevations, and this is how we're going to label the interior elevation. Also in the interior elevation symbol, especially as we get into more technical drawings, we want to take a look at how to get from point A to point B. So this becomes more of an important reference guide. But the room number is referenced in part of that symbol, and the sheet on which that interior elevation is occurring is also referenced inside that symbolic bubble. And so you can see that at a smaller scale here also. So how does that really work? So we know the symbol, but how does it work with a plan? So we will be doing two sets of interior elevations today. For purposes of the demonstration, we're going to focus primarily on the kitchen area, and you will be taking the information that you have here and applying it to the washroom area in a very similar way. So as we look at the kitchen area, I'm going to cover up this symbol for just a moment. I want you to observe that the plan is right reading. All right, so there's nothing, we're not doing anything tricky with the orientation. Look, you can read all the symbols and all the information correctly. So that's why what I'm referencing the right reading for, because your interior elevation symbol needs to refer to the drawing in that orientation. So we place the symbol on the plan. Now, you do not have to do this on schematic design information, which is primarily what we're working on. So you do not have to put this on your plan, but you need to understand how it relates to the plan. So if you wanted to, you're certainly welcome to take a piece of trace paper and put it on there. If that would be helpful to you, that's your choice. But understand that A is always at the top. B, again, is at the 3 o'clock or the right directional side of the symbol. The C is at the bottom, and D is at the left side or the 9 o'clock orientation. So what that's really doing is that when I want to look this way at an elevation, that will be A. If I want to look at the right side of the plan, I'm going to reference a B elevation, and that represents from this wall to this wall. Similarly, C would be looking this way and goes from this side of the plan drawing all the way to this side, and D would be going from this side to this side, illustrating all those features of the design. So sometimes we end up with drawings that are very small, and the space just doesn't permit enough room to put the symbol in the middle of the space. So in that particular case, we set the symbol outside, but understand its orientation and directionality are exactly the same as if you put it in the center. So if we were taking this symbol and applying it to the washroom area, we would come down with a leader and indicate that, hey, this set of interior elevations is applicable to this space. Now, with that in mind, we would also follow the same rules that we used when we were looking at the kitchen. That means that this, by representation, is the A elevation. This is the B elevation, this is the C elevation, and this is the D elevation. So A, B, C, D. And whether the symbol is placed outside somewhere or on the plan itself, those orientations do not change. So as a result, we have a standardized symbol that is used pretty much throughout the industry and is referenced A, B, C, D. Now there are some variances on that, and that's covered, I think, in the lecture. But for our assignment, A, B, C, D are our primary elevations that we'll be working with. Okay, so as a result, there will be more on the actual arrangement on the sheet a bit later, and that's again covered in the formatting sheet that is provided to you in the assignment. So referring back to my notes, one of the quick other things I forgot to mention is that we don't always elevate every interior elevation. Sometimes the elevations are not that important. They don't show anything special. So as a result, we need to think about what is important in the plan view that needs to be looked at. And as a result, we end up with some walls not being elevated. If we had a lot of time and a lot of drawing space, we could do all of them, but for expediency purposes, most architects and designers only do those drawings that are absolutely necessary to articulate the design fully. So let me talk a little bit. I forgot to mention just previously that the way we indicate that is by pocheting the directionality. So when we poche this side of the symbol, we are indicating a D elevation will be drawn as part of the interior elevations. In this particular case, we're seeing that the C elevation would be called out. Now, as we look at the examples that we're going to be working with today, we're not going to do elevation A because there's not that much. It's kind of wide open there and it's not going to indicate very much in the drawings for purposes of describing any of the design features. But B does show a lot of design pieces. And so as a result, we're going to poche the B designation and we're going to elevate that wall. As you can see, C is pocheted and D are pocheted. So in a similar way, we're going to elevate the elevation C and elevation D in this assignment. So hopefully that helps to clarify how the symbol works and how we come up with these types of designations. So moving on now to other parts of the assignment, let's actually start on the requirements for this drawing. As I mentioned, this is a multi-view drawing. These drawings require that we take a look at multiple references, and this should be nothing new to you as you have been using since the section elevation. We've been using other references to help guide us through the drawing and help us understand what are the exact design parameters and features. So the first thing we're going to do is we're going to go back to the floor plan because that's an important piece and we will be using the information very directly on that. In addition to that, we're going to also need to refer back to our section information, both graphic and text information, because that will be helpful in learning about certain heights. So just like we did on the elevation, exterior elevation drawings and on the section drawings, we use the plan to locate the feature kind of left to right, and we use the additional section information to provide height requirements. And so that should help us in getting or navigating our way through this assignment. So as we start remembering our symbols here, we want to think about how do we orient the drawing in such a way that it becomes helpful to us. Now, in this exercise, I'm going to be using 8.5 by 11s instead of the 11 by 17. Later in the assignment, we will look at the larger drawing for all the things that need to be formatted and provided on it. But for right now, we're going to use just 8.5 by 11s because they're more they're easier to work with and they're easier to align than the large sheet. So, as I've mentioned in our example here, we're not going to be doing A. So our drawing needs to be turned and oriented in such a way as to make it easy to reference and oriented correctly for the elevation that we're going to be drawing. So, with that in mind, let's start. As mentioned, we're going to be starting with elevation B, which is this elevation here. Now, that means that we need to rotate this drawing, or the plan drawing, in such a way that we have a horizontal representation of the elevation that we're going to be looking at. And we're going to want to tape that down that way so that we can then go on to the next step of the drawing. So as we've done in the past, let's go ahead and align the drawing and tape it down so that we can have it ready for the elevation drawing. Okay, so there it is. Now we're going to take a new sheet, 8.5 by 11, and place it in such a way that that elevation is approximately in the middle. All right, so it's the elevation actually for this kitchen is not just of this wall, but actually extends all the way over to this wall here. And since we're looking at it from here to here, we're going to need that full expanse of space to make that work. So let's go ahead and tape down a sheet of vellum for that elevation. Squaring it up. That gets us right, and we'll provide the next piece. Okay. The tools that we'll need, very basic. We need the architectural scale, 1/4 inch. Need the triangle, 90 degree or 45 or 30/60 is fine. Doesn't really matter in this particular case, although I think 45 will probably be a little bit more handy. Then just we need our pencil and eraser to do the drawing. Okay, so as we start, one of the things we want to refer to is the section drawing. And in the section drawing, one of the things we determined was that there is a ceiling height in the kitchen. And that ceiling height was provided in the graphic. You could either scale it off the drawing, or we could take a look at the specific heights that are provided in the plan. If you look at the information here, it says that the ceiling height in the kitchen is 8 foot above finished floor, and that there's a soffit at 7 foot 7 foot high represented there also. So we'll come back to that in a bit, but just understand that we're working with a 8 foot ceiling height. So to draw this elevation, simply start somewhere lower down here underneath the drawing and draw a line across and set that as your finished floor height. You might want to mark it FF for finished floor so you know what that represents. Now, we know that the height of this ceiling is 8 foot. So what we're going to do is we're going to measure, mark, and draw another horizontal line at 8 foot above that finished floor. So having found that height, we mark it and we draw our ceiling line. So we have a floor height and we have a ceiling height represented here. So two parts of our boundary are established, our bottom and our top. Now, our next activity includes looking at the floor plan below and finding the left and right boundaries that will help us establish the full, I'll say, parameters of the interior elevation. So looking at the elevation, we want to only focus on the interior side of the elevation affected. So we're not concerned about the outside wall. We're more concerned about this inside line, and that's the boundary line right there. So we're going to mark that as our left boundary line of this interior elevation. And so we're going to line it up and we're going to draw from the floor to the ceiling and stop right there. And we're going to do the same thing on this side. So our plan indicates that the wall, again, inside, not the outside of the wall, but the inside of the wall for that kitchen area occurs right here. So we're going to do the same thing. We're going to draw a line from the ceiling down to the floor, from the floor up to the ceiling, however it works for you. And that's going to define that rectangular form, is going to give us the limits or the boundaries of our interior elevation. So with that in mind, we're only focusing on just this little area. So it's very simple. These drawings can go rather quickly. So as we've done in the exterior elevation, we found all our vertical edges of those features, and we marked them with a vertical line that gave us a place to define the edge of that feature. So I'm going to start on the left side and go towards the right, and we're just going to look at all the elements that would be exposed in this interior elevation. So kind of projecting your view into that space, the first line we've established as the inside wall. Next, we're going to see a line for a refrigerator. It's right there. And then another line right next to it, which represents some cabinetry. Let me get that on there just a little different. Okay. Next, we're going to have another line for the edge of the cabinetry. So we're going to mark that. And, you know, the next item is the range or the oven, and that's going to be right next to the cabinet, and it's going to extend all the way over to this wall. Now this wall, we're going to see an end wall condition in it, and you'll see how we do that in just a minute. But basically, we're going to stop the range right at the inside of that wall. So I've marked that one. Next, we're going to show the extent of the wall. So we see the end of that condition. And then moving across, we're going to see some cabinetry, then a final wall. So let's measure. Well, we don't have to measure, we can just mark it. So the first line we come to is that line where the cabinetry is. So let's just extend that line up. And then we have the final line for the wall itself. So what we have in the plan so far is the left side wall, the refrigerator, just marked as edges, the cabinetry, the range, the little end wall condition, the opening for accessing the kitchen, the pantry cabinet, and then the finish wall there. So all those are lined out now. Now what we're going to do is we're going to use our section drawing, just as we've done before, and the text information to find what our heights are. So let's start with the idea that the cabinetry is pretty well defined. If you remember, the cabinetry is going to be at 36 inches. So I can mark that. Move my parallel here. And that's going to be at 3 feet on the elevation. Rather small piece of cabinetry, but we have another piece of cabinetry above that, and that starts, I believe, 18 inches. Yes. So right here, it tells us that 18 inches above the countertop and extends to the soffit line. Now, if you remember, we talked about the soffit line coming down to 7 foot. So we could go ahead and draw that in as a line as well. So let's go ahead and set that. We know that the ceiling line is right here. And we're going to come down 1 foot and set that. Now, for purposes of being able to see this a little better, I'm going to take just 1 minute and draw this information in a little bit bolder so you can see the drawing just a bit better than my rough marks on the drawing. Okay, so we'll put that soffit line in. There it goes. Now we're going to put in our countertop. We have, let me go ahead and put in the base of the counter. Okay, we have an end wall condition here. Let's see if we can grab our example drawings here. Right here, so we can look at those a little closer. Okay, so what we observe in our example is that we have a refrigerator. You can see that here. We can see some cabinetry. We have overhead cabinetry in kind of an interesting formation. But I think if you look at your cabinetry in your home, you'll find that if there's cabinetry over the refrigerator, it tends to be a little bit shallower or lifted up higher so that the refrigerator fits underneath it. And that the cabinet that's remaining over the base cabinet, that overhead piece, is one that fits within the conventions of regular heights that we have on our section elevation. We also have, so we have a refrigerator, we have a range or an oven, and then we have a hood. And so we'll talk about those in just a minute, but we're just blocking out the elevations right now. Good to have this around so we can take a look at it. Okay, so one of the things I did observe here is that our soffit doesn't necessarily extend all the way across the opening. So I'm going to go ahead and pull that back a little bit and elevate that just a little bit differently. So all right, so we have the main part of the kitchen covered here in terms of the construction. We'll add the appliances in just a minute. And we have an opening, and then we have a pantry adjacent to the sidewall here. You see it right there. So I'm going to go ahead and draw it in. It does have a soffit there, so we need to observe that. Yes. Okay, so we have the cabinet. Some pieces that we need to put in include, as we look at our examples, is we have a toe kick that's 4 inches high. It occurs in the side view of the cabinetry here and in the front view of the cabinetry here. So I'm going to measure that. And those tend to be about 4 inches. 4 inches by 4 inches. Clean that up a little bit. Okay, and then we have one last bit. We need our overhead cabinet here. Yep, that's it. Okay, good. Sorry, I had a misreference on some of my heights here. It can get a little confusing sometimes, even for someone who's done it a number of times. So we want to make sure that our heights are correct. And here's the soffit line. Here. So ceiling, soffit, ceiling, soffit. Okay. Now, as I was looking at our example, I observed my overhead cabinet was just a bit shorter than I thought it should be. And so I wanted to make sure I got that in correctly. Okay, so ceiling soffit. And there's our soffit. Okay, so floor, soffit, ceiling, cabinet overhead, cabinet base, and then here's our pantry. So that we used the plan to line up our the objects we're going to be drawing, and we placed a vertical line to mark their location. Then we used the section information to find our heights, and some last minute things that we need to do here are to kind of think about some appliances. Now, generally speaking, some things to think about are that um, there is some range in appliance sizes. Some appliances are more geared towards a custom installation. I'm going to let you take a look at your appliances in and around your kitchen area and see how tall they are. The width should be pretty common to what we've drawn here, but the heights might vary a little bit. So take a look at that and see, how yours might vary slightly from ours. Then, as we look at that, we want to consider the types of appliances. For example, let's looking at the refrigerator. This has an upper compartment and a lower compartment. Some are side by side. There's a whole variety of different types and so on. I'll leave that to you. I'm not going to get too worked up over the specific size. But the one thing I did want to point out is that if you look relatively close, that any overhead cabinetry tends to have about 6 inches of clearance between the bottom of any overhead cabinet and the appliance itself. And this permits for ventilation and exhaust of warm air in and around the coils of the refrigerator. So as a result, I'm going to just measure down in this particular case probably about 18 inches for the overhead height on that cabinet. And I'll let you have some flexibility there. Okay, so what we have is we've got overhead cabinets. We're going to go ahead and put in just a reference for the kitchen appliance, for the fridge, and for this purpose, we're just going to draw something kind of simple. Now, looking at the range, generally speaking, ovens and ranges line up with the countertop. So again, take a look at what you have at home. I'm sure it should be close to what's represented here. So the countertop and the top of the range are often at the same height. So with that in mind, I'm going to extend the countertop over to the edge of the wall, and then I will permit you to do that same exercise that you did for the refrigerator with the appliance or the oven appliance. And you can see there's some basic information provided here. Take a closer look at it and add the elements in. There's some control devices. There's a drawer down below. There's an oven door, and there's even a backsplash panel that goes along the back of the wall. And that tends to be about 3 or 4 inches high, depending on the model. But our plan will also include a 4-inch backsplash. So let's double check here. On our cabinets, we say we have a cabinet here. Oh, we have a base that's 4 inches high. See where's our splash says that we have 4-inch high. Let's see. Base cabinets 36. Countertop thickness is 2. Overhead is 8. Okay, over depth, we're not worried about that. Yeah, so let's just make it 4 inches for lack of a better representation. So with 4 inches for the cabinet backsplash, which protects the wall and usually occurs at the back of the lower base cabinet, usually wants to match the toe kick in height, so you get a little bit of comparable heights there. And then we're going to extend that back along the back of the oven range as well. So using the drawing, you can kind of start to pick up parts and pieces as necessary. The thing that I would also suggest is take a look at the hood assembly. We've shown one here that's rather simplistic, and that's fine. There's different types of ones, so take a look at one that's that you may have at home. If not, feel free to copy this one. That's fine and acceptable for the assignment. The last little bit is something that we've talked about in our lecture or our lab assignment for the section, and that is the topic of doors, cabinet doors. And just a quick review would indicate that we show the door hardware in the center because typically there's some hardware that assists us with how that door operates. And then the hinges tend to be on the outside. So as a result, we end up with an indicator of some sort of hardware. And the dashed and dotted lines that kind of come down to a point, those are indicating where the hinges are, and that shows how the doors operate. And so you can see that over the refrigerator we have double doors, and over the low counter it's not big enough for double doors, so we just have a single door there with the hinge side indicated as represented in the drawings. Now, one other thing that you're going to observe is that the blockout that occurs at the opening, this space right here is represented by a just an X that and that usually indicates that that's open and that there's nothing there. You could leave it there, but it might be interpreted as a wall or something like that. So by putting an X there, we're indicating that it's a void or an open space beyond. And then we do get a little bit of a view of the side view of the cabinet. I'm not going to get into the cross sections of that. That would be something we do in the 220 class. But in this particular case, it's nice to represent that there is something there underneath that soffit. Okay, so after we have drawn in our elements here for the various appliances, let me finish this piece here, and it goes up to there. Get that cleaned up. So what we have is we have the general shape of the room. We have some soffits in there. We have a block out for where the appliance side is right here. We have an opening and we have a pantry. Hopefully that makes sense the way we've kind of arranged it and how it's gotten placed on the drawing. At this point, it's good to take a closer look, as we've been talking about, at the specific details about the hood, about the range or an oven, and about the refrigerator, and taking a look at how those are represented and shown. So we want to make sure that all that information gets put in this rough block out, so when we go to draw it later in the final drawing, that all the parts and pieces are there. So after you've completed this, it's appropriate to take this drawing, set it aside for reference, and then we'll move on to the next elevation. And I'm going to close this piece of the video and start up the next elevation in just a moment. As I close, there will be another part coming along, so please stay with the video as you see it close this portion and start the next one, and you'll find a very similar set of criteria that we use as we're drawing this next section, and it'll go probably a little bit quicker, and then the last elevation will go rather fast altogether. So with that, I will say please tune into the next video for that next section. Thank you, and we'll be back with you in just a few minutes.